A typical DRAM cell consists of one NMOS pass transistor for switching charges and one cell node capacitor for storing charge.
In modern DRAM cell designs, there are two types of node capacitor structures for storing signal charges. For an example, stack capacitor or deep trench capacitor as sketched in figure after this.
This is the diagram of a DRAM cell. The green circle is an NMOS pass transistor for switching charges. The red circle shows the node capacitor structures for storing signal charges. First is stack capacitor, second one is deep trench capacitor.
How DRAM chip will be, huh?
DRAM chips are large, rectangular arrays of memory cells which support logic that is used for reading and writing data in the arrays.
Wow! So smart, huh?
Wow!
Okay lah, can you explain to me what is memory array?
Memory arrays are arranged in rows and columns of memory cells called word lines and bit lines respectively.
Think smart, huh? So what is memory cell, huh?
Memory cell is a capacitor that is charged to produce a 1 or 0. In today's technology, trenches filled with dielectric material are used to create the capacitive storage element of the memory cell.
As an example, the address lines A0 and A1 through the row address selection. The multiplexer selects the address lines of a whole row of cells. When reading, the content of all cells is made available to the column address selection multiplexer. This is the internal diagram of a DRAM chip.
This explains how data is being read from the DRAM.
In a DRAM, to write a memory cell, the chip's onboard logic either charges the memory cell's capacitor or discharges it, depending on whether a 1 or 0 is to be stored.
Now, I'll explain about refreshing the memory. Since DRAM memory cells are made of capacitors, the charge that contain can leak over time. So what we have to do is, we have to refresh the DRAM over time to prevent the data being lost from these capacitors. So this refreshing period depends on the silicon technology because each has its own frequency.